Hello, I'm Carl Evans, founder of Tercero Technologies, an edge artificial intelligence startup based in Chicago. Today I'll be talking about the computationally efficient deep learning powered EWS radar data preprocessor, or SELLER. This work is being done under SBIR topic N192-048, with the original topic name being Automatic Track Generation Micro Preprocessor for Dismounted Electronic Warfare. This work is being funded by the United States Marine Corps Systems Command under a Phase 2 SBIR. There's an AI arms race between the United States and our near-peer competitors such as Russia and China. As a result of this, the United States Department of Defense will invest billions of dollars in artificial intelligence research and development and acquisitions, particularly related to AI-enabled smart sensors and autonomous vehicles. Furthermore, the Joint All-Domain Command and Control, or JADC2 concept, will introduce new AI capabilities to the next generation Internet of Battlefield Things. However, many of these capabilities will be battery-powered, making efficient machine learning inference on size, weight, and power, or SWaP, constrained devices at the tactical edge increasingly important. Embedded graphics processing units, or GPUs, have been a game changer for embedded machine learning inference because existing development tools make them easy to use. However, in many cases, they are not the best solution in terms of compute per watt. At Tercero, we're developing software tools to make it easy to convert machine learning models developed using industry standard platforms such as TensorFlow into efficient FPGA-based designs. This will allow our defense customers to more quickly deploy new AI capabilities to the warfighter. FPGAs are essentially reprogrammable chips where algorithms are implemented in hardware rather than software, generally making the algorithms faster and more energy efficient. There are two key innovations to our Phase 2 SBIR development. First, we have developed and are continuing to develop a tool to automatically generate efficient FPGA hardware designs from machine learning models. Then, we are implementing a machine learning-based target tracking system that will be implemented in FPGAs using the tool that I just discussed and will discuss in more detail in the coming slides. We call this tool Accelerado, and we're excited to introduce it. As I mentioned, Accelerado is a tool developed to automatically convert TensorFlow models into efficient hardware designs. It uses the latest in AMD Xilinx hardware and software development tools and is powered by proprietary extensions to the Apache TVM machine learning compiler. Potential applications for Accelerado-based FPGA inference include radar systems, conditions-based maintenance, unattended ground sensors, and given my personal background as a roboticist, I have a particular interest in autonomous vehicle controls and multimodal sensor processing and perception. Let's return now to the first application to benefit from Accelerado and the challenge for this SBIR topic, electronic warfare systems. So electronic warfare systems can provide critically important information about potential threats in the vicinity of dismounted Marines. However, the systems can also generate potentially billions of data points related not only to those threats, but also resulting from electromagnetic and environmental clutter. Transmitting potentially large volumes of data to Tactical Operations Centers, or TOCs, for post-processing can potentially pose challenges in responding to threats in real time. So at Tercero, we're developing an edge AI-based system to essentially filter the signal from the noise to provide real-time notifications of potential threats. Our solution, the SELLER preprocessor, will be able to track slow-moving objects in the presence of moving point clutter with the ability to identify and rejoin intermittent and disjointed tracks with a target false alarm rate of less than 5% during a 24-hour period of time. The SELLER preprocessor will use a modular open systems approach, or MOSA, to allow it to easily integrate with existing and future dismounted electronic warfare systems, all in a relatively small size and weighing less than 5 pounds. Lastly, the SELLER preprocessor will support Joint Interface Control Document, or JICD, 4.2 compliant messaging. This slide shows our status as of several months ago. On the left, we have our web browser-based graphical user interface front-end, where a user can upload a TensorFlow model and specify parameters for the automatic conversion to an AMD Xilinx FPGA hardware design. Once the user submits the conversion parameters, our backend software automatically implements the machine learning model in hardware, a process that could take anywhere from a few minutes to a few hours depending on ML model complexity. The right side of the slide shows an early concept of the seller hardware design, as well as a tablet-based user interface for displaying target tracking inference results. Transition opportunities for the technologies we are developing under this SBIR effort include a Marine Electromagnetic Warfare Ground Family of Systems, or MEGFOS, unattended ground sensor programs, autonomous vehicle navigation and perception efforts, and any application of classical or deep learning inference in the field on SWaP-constrained devices. We are also reaching out to defense primes such as Raytheon and Kinetic, and we'll also reach out to commercial sector companies such as Caterpillar and John Deere. Lastly, we recognize the success of companies such as Anduril, Palantir, Shield AI, and SpaceX as models for how we plan to grow Tercero over the coming years. So what's the status of Tercero? So we're currently completing this Phase 2 SBIR effort and are participating in the U.S. Navy's SBIR transition program, as well as working to commercialize our technology within the U.S. Marine Corps, the U.S. Navy, and other DoD components. We currently have 2 employees with plans to at least double our size by mid-2024. As we continue developing our technologies, we are currently looking for transition partners for Phase 3, particularly hardware vendors using AMD Xilinx FPGAs or those interested in using AMD Xilinx FPGAs. We are also currently starting to fundraise to grow our engineering team and pursue new opportunities with the DoD, defense contractors, and commercial sector partners. If you are interested in learning more about Tercero, the Seller Project, or Accelerado, please feel free to reach out to me at the email address shown on this slide. Thank you.